Hey there, so let's cover the trig exam as well as I want to discuss what's going to happen on our final. After this last exam, it was redonky donk how many people asked me questions. That will not be the case on the final. Here's what's going to happen on the final and for any exams I do going forward because I'm not going to do that again. You're going to get one little sticky note and that allows you one question on the exam. That's it. And it's not going to be how to do something. It might be a hint. It'll be a hint. If you have a question about understanding whether or not you know what I'm asking for, that's one thing. But if you're asking me for any kind of guidance or a hint, you're going to get one option, and that's it. You're only going to get one. So once you ask me that question, I'm taking that sticky note, and you will no longer have any options to ask me questions the rest of the exam unless it's for clarification on what I'm asking. If you still have your sticky note at the end of the exam, I'll give you a +2 bonus on that exam. Um, that's where I'm at. So you will only be allowed to ask me one question. Make sure that you've gone through the entire exam for the final before you decide what question you're going to ask me. And I will not ask any further than that. Okay? So be prepared. All right, let's get to exam 4, trigonometry. It says convert the following angle to radians. So the first thing you need to see here is use exact values. Show all work. Use exact values unless otherwise instructed. Provide correct units and sentences when needed, which I refer to in here, and rationalize your denominator for bonus points. Okay, so convert the following angle to radians. It is currently at 160 degrees. We want to convert to radians. No decimals, reduce if necessary. So I'm going to take my 160 degrees. Anytime you're going from degrees to radians, you just multiply by pi over 180 degrees. When you do that, you get 160 pi over 180. I'm going to go ahead and start reducing. I know it reduces by 10. Well, if it's reduced by 10, that's going to give me 16 pi over 18. But I know that that's reducible by 2. So 16 divided by 2 is 8. And 18 divided by 2 is 9. And that's as low as we can go. There's my radians version for this. The majority of you got that one right. Convert the following angle to degrees. It doesn't matter if it has a pi or not. This is still radians. I went over this when we went over radians initially. So you should know if you're converting to degrees or to radians, you're doing this. If you're converting from radians to degrees, you go negative 2.3, and this is radians. There's no pi symbol there. I don't know why some of you put that. Times, and this one's going to be 180 degrees over pi. So it says round to the 10th, which means you're going to use your calculator, okay? So negative 2.3 times 180 divided by pi equals, and that is negative 131, rounding to the 10th, 0.8. And this is degrees, so you need to give your degrees. All right, find one positive and one negative coterminal angle. So all I need to know is, I don't even need to know which quadrant we're in. I just need to know, I want to know where we're in or around. So it's probably right about, well, if I could draw a straight line, it's probably right about there. Okay, so to find one positive, I just need to add 360 to my 160. So 520 degrees is my positive. My negative would be going the other direction. So that's going to be 160 degrees minus 360 degrees. It's negative 200 degrees. All right. A circle has a radius that's 8 centimeters. A central angle of 75 degrees intercepts an arc. During the review day that we covered this, I made sure that I didn't just have you do one with degrees, I also had you do one, with radians, which is what I gave on the review. We also did one with degrees, and whenever we did that, I told you that the angle has to be in radians when you're doing this. Okay, so S equals r theta. My radius is 8 centimeters, so 8, and my theta is going to have to be the 75 turned into radians. So I'm just going to go 75 pi over 180, and that in itself will turn it into radians. All right, because that's what we did up here, times pi over 180. So 75 times pi over 180. I'm not reducing. That's when issues happen, and I told you that during the review as well. I don't know which is better here for y'all. Let's get out the light. So 8 times 75 times pi divided by 180 is 10.47. And then we wanted to round to the hundredths place or 2 decimal places, so 10.47. So S equals 10.47, and now we need the unit, which is centimeters. All right. In a right triangle, an acute angle is 42 degrees and the adjacent side is 9 meters. Find the opposite side and round to the tenths place. So we've got a right triangle. All right, there's my angle, and it says an acute angle is 42 degrees. The adjacent side is 9 meters. So this means is our hypotenuse and this is our opposite. Find the opposite side, which is this side here, and round to the tenths place. Well, if we are looking for the opposite and we have the adjacent, which function is that? Sine, cosine, or tangent? And that is going to be tangent. So the tangent of the angle is the opposite, which we're looking for, over the adjacent, which is 9. We have to multiply both sides by 9. And I'm going to go ahead and put this in my calculator. The opposite side is, make sure I'm in degrees. Yes, I am. 9 times tangent of 42 is 8.1, and we're just going to the tenths place, so 8.1. We just needed to give our unit, which is meters. Okay. Excuse me. Get my nose here in a minute. All right. A sleepy zombie is trying to climb onto the roof to take a nap in the sun. So, trying to get up here, and he's going to need a ladder. Don't ask why. A rickety ladder makes a 40-degree angle with the ground. So there's my ladder, and it makes a 40-degree angle with the ground and touches the roof 15 feet up the building. So that means this is 15 feet. All right. How long is the ladder the zombie is using? So that's the question, is what is the length of the ladder? This is our right angle, which means that is my hypotenuse. So I've got opposite, I need hypotenuse, so therefore my trig function is sine. So sine of 40 degrees is opposite over the hypotenuse. And I need to solve for my hypotenuse. So I need to multiply both sides by my hypotenuse. And then to solve for hypotenuse, I'm going to get h sine of 40 degrees is equal to 15. To solve for h, I need to divide both sides by the sine of 40 degrees. All right, so my hypotenuse is, make sure you're in degrees again, 15 divided by sine of 40, and that is 23.33. So I said round your answer to the nearest foot, so that would be 23. If you had used problem solving method, which I don't think any of you did, your answer could have been 24, because a 23-foot ladder wouldn't have been long enough. You would have still been missing some, so 24 would have been a correct answer, actually a better answer. But I accepted 23 or 24 as my answers for these. And it says round your answer to the nearest foot. Also, to show your work, which I did, and write a sentence. So this was 23. I'm just going to leave it as that. The ladder is 23 feet, or you could have used 24 feet. All right, next one. A dramatic llama. Now, when I drew a picture of this on the board, I got some crazy answers, and I am not going to do this one, okay? What I did was I took your drawing, and the majority of you, I'd say about, there's 3 or 4 different versions that I saw. And I gave the majority of you, if you did what your drawing said, I followed your logic, and I gave you the full credit for this. So the majority of you got full credit for this. If you did not, that means there was something seriously wrong with the procedure in itself. Okay. I think there was a couple of y'all that I put on there that your drawing didn't match what you did, but I honestly can't remember at this point what I did for points wise. I was looking for a complete sentence, I was looking for a correct unit, and I was looking for you to make sure that you had rounded to the nearest tenth. Okay. Let's go down here to this one. This was a struggle. It says evaluate exactly. That just means you look at your unit circle where 120 degrees is for your first one. 120 degrees is here. Remember, your x value is your cosine, the y value is your sine, and I asked for your sine of 120 degrees. So that was square root of 3 over 2. Okay, so square root of 3 over 2. The next one was cosine of negative 120 degrees. So if going this direction and landing here is 120 degrees, if I wanted the negative version, I'm going to go the same distance around and stopping at the one that's the same distance, which is going to be this guy right here at 240 degrees. And I asked for the cosine, so that means the x value of this angle, which is negative 1/2. All right. Find the reference angles. If you are given an angle in degrees, your reference angle needs to be in degrees. All right. If you're given a reference angle in radians, your reference angle needs to be in radians. It's that simple. I've said this before. All right, so for this one, 315 degrees, I need to know which quadrant that is in, and that is in quadrant 4. So that means whenever I'm finding my reference angle, it's just 360 degrees minus my reference angle. Minus my angle to find my reference angle. So it would be 360 degrees minus 315 degrees. So my reference angle is 45 degrees. For the next one, I didn't care that you went to degrees, and then the problem is you didn't go back to radians for your answer. Okay, so I'm just going to do it in radians. It's in quadrant 3 for 4 pi over 3 is in quadrant 3. So to find your reference angle for quadrant 3, it's the absolute value of pi minus your angle. If it's in degrees, it would be the absolute value of 180 degrees minus the angle. So in our case, it is pi minus 4 pi over 3. Now, there is a 1 in front of pi. That means I can put anything I want in front of it as long as it's equal to 1. I want my denominator to be 3, so therefore I'm going to choose 3 over 3, which is 1. 3 minus 4 is negative 1, so negative pi over 3. And the absolute value of that is pi over 3. So that is my reference angle. Next one. If cosine of theta is 5/8 and theta is in quadrant 4, find the other trig functions. Well, cosine of theta is adjacent over hypotenuse. So that means my adjacent side is 5 and my hypotenuse is 8. Therefore, I'm going to put my angle right here. The adjacent side to that angle is going to be 5. I need to find my other side. So I'm going to use the quadratic. A squared plus b squared is equal to c squared. Okay. And we'll just let 5 be a. My hypotenuse is C. 5 squared is 25. 8 squared is 64. Subtract 25 from both sides. B squared is equal to 39. All right, and take the square root of both sides, and we get B, that the opposite side is the square root of 39. I did not want decimals. You've never seen me use decimals. Please don't use decimals. Only use the actual number, not exact. I use the exact, not the approximate. All right, so let's find the other 5 trig functions. So sine of theta, because we don't know what theta is the opposite over hypotenuse. My opposite is square root of 39. My hypotenuse is 8. Let's find our tangent. It's the opposite over adjacent. I'm going to find the cosecant, which is the reciprocal of sine. Secant is the reciprocal of cosine, so 8 over 5. And lastly is cotangent, is the reciprocal of tangent. All right, not quite done. My angle is in quadrant 4, so I need to know who is positive in quadrant 4. Only cosine and secant are positive in quadrant 4. Everything else gets a negative. Okay, those are the answers for this. If you wanted bonus points, you have 2 options for this, and that means you're going to rationalize your denominator. So multiplying square root of 39 over square root of 39 is negative 8 square root of 39 over 39. For cotangent, multiplying by the square root of 39 over the square root of 39 is equal to negative 5, the square root of 39, all of that over 39. Okay. Evaluate exactly with no decimals, tangent of 210 degrees. All right, so I have to look at 210 degrees. My cosine is negative square root of 3 over 2, and my sine is negative 1/2. So I'm going to start with tangent of 210 degrees. That's equal to sine of 210 degrees over cosine 210 degrees. Sine, as I just said, is negative 1/2 divided by cosine is negative square root of 3 over 2. Keep, switch, flip. Negative times a negative is a positive. Many of you missed that. That was huge. That hit a lot of you, but it was only a point. These two reduce, and you're left with 1 over the square root of 3. That is the correct answer. That's for 6 points. For an extra point, you rationalize your denominator, and you get square root of 3 over 3. Number 12. State all values of theta where each function is unidentified. Well, secant of theta is equal to 1 over the cosine of theta, right? So I need to know where cosine is 0, because a 0 in the denominator means it's undefined. Well, cosine is my x value, so I just need to look on all of my x values to find the ones that have a 0. 270 degrees has a 0 in the x value, and 90 degrees. So 90 and 270 degrees. All right, you could have chosen to use your radians. It didn't matter to me. Very few of you did. Cotangent is going to be the same. Let me see how I explain this on here. Oh, there we go. Cotangent is going to be cosine over sine. All right, cosine of theta over sine of theta. So I need to know where my sine is 0 to make this undefined. And that's going to be my y values. So my 0, my 180, and my 360. So 0 degrees, 180 degrees, and 360 degrees as well. Okay. If you just wrote these two or these two, I gave you credit. Just be careful. Evaluate with your calculator. Good Lord have mercy. It's this one, oh my gosh, I had to do shots at the time. Round to 4 decimal places. So that means only use your calculators. So calculators commence. I'm already in degrees, so I'm going to use degrees. I'm going to do this one first. Secant is the same thing as 1 over cosine of 125 degrees. So I'm going to put 1 divided by cosine 125 equals negative 1.7434. Round to 4 decimal places. Negative 1.7434. That's it. Cotangent is the same thing as 1 over tangent, right? That's the reciprocal. Some of you went cosine over sine and did a whole bunch of work that I wished you hadn't done. I just wanted you to put it in your calculator. That was it. So tangent of 7 pi over 6. The trick here is to make sure your calculator is in radians. So I'm going to go to radians and hit enter. Now I'm going to put 1 divided by tangent, and then inside the parenthesis is going to be 7 pi over 6. And I got 1.732, and then you needed to round to 1 because it's 4 decimal places. So 1.7321. That is it. Next, use the reference angles. Okay, a lot of points here on this one as well. If you got a highlight, that means you missed 6 points because you didn't use your reference angles to show this work. It says work must be shown using a reference angle. Use a reference angle for 4 pi over 3 to find your 6 trig functions. And then you have to answer the question using the original angle. So I start with finding my reference angle for 4 pi over 3. 4 pi over 3 is right here. And I think I had to go back. Did I find that one earlier? Yes, I did. So back where I had 4 pi over 3, I've already found the reference angle. So I'm going to use that reference angle, pi over 3. So sine pi over 3, cosine pi over 3, tangent pi over 3, cosecant pi over 3, secant pi over 3, and cotangent pi over 3. Do not just write sine, cosine, tangent. Of what? You're not telling me anything. You need to do this first using the reference angle and looking at where pi over 3 is. My cosine is 1/2. My sine is square root of 3 over 2. Okay, now let's do the rest of them. My tangent is sine over cosine. So sine of pi over 3 over cosine pi over 3. So that's going to be square root of 3 over 2 divided by 1/2. You have to do the keep switch, take the reciprocal. So square root of 3 over 2 times 2 over 1 is equal to the square root of 3. Cosecant is 1 over what? 1 over sine. So that's 1 divided by the square root of 3 over 2, which is 1 times 2 over the square root of 3. So that's 2 over the square root of 3. Secant is 1 over cosine of pi over 3. So 1 divided by 1/2 is 1 times 2 over 1, which is 2. Cotangent. You could do the reciprocal of tangent, which is totally cool, or you could do the cosine over sine. We're going to get the same answer, so I'm going to do 1 over tangent of pi over 3, which is 1 over the square root of 3. Okay, that is my reference angle work. Now I have to rewrite the same information, not all of it, just sine of the angle that we're referencing, 4 pi over 3, cosine 4 pi over 3, tangent 4 pi over 3, cosecant, 4 pi over 3, secant, pi over 3, and cotangent. All right, I'm going to rewrite these real quick. Sine is square root of 3 over 2. Cosine is 1/2. Tangent is square root of 3. Cosecant is 2 over the square root of 3. Secant is 2. And cotangent is 1 over the square root of 3. I'm not done. I need to check my signs because it's definitely not all positive. 4 pi over 3 is in quadrant 3. Who's positive in quadrant 3? Tangent and cotangent. So everyone else should have a negative. Okay? So those are the answers, and that's how you should be doing this work using the reference angles. Lastly, you can get 2 bonus points by multiplying and rationalizing your denominator. So -2 square root of 3 over 3, and times square root of 3 over square root of 3 is square root of 3 over 3. Okay? That's everything for that. All right, that was the exam. If you have any questions, please let me know. You'll get your exams back before you take the final. I want you to see the mistakes that you made. Please read what I've written. It is important for you to have that knowledge base going into your final. The next video you'll see from me is going to be the final exam review.